So, welcome again. So, yeah, just made a makefile. And what are we gonna do today? Today, we are going to parse custom binary. Yay! So, first things first, I would like to split the code a bit. So just like the architecture is cleaner and stuff like that. So let's start by saying, I don't know, engine to do that C to do that H. And what we're gonna do actually is, let's delete these. Engine to do that C's. Yay. Main.c. Engine to do that H. Okay. Next thing. What we're gonna do is, so this is great and all, but so we have like a structure of what an item looks like, but let's do something like this instead. So we have a title, a boolean completed, and let's say unsigned integer title length. Now let's say to do title length, let's say 255. I don't know. To do max title length. We can probably get this out of here. So this is like the to do item, and basically how it looks here is how it's gonna look on the disk. And let's first do stuff like this. So we have a create to do, but what I would like to do actually is something like this. So this is the title, and what we can do, let's say to do create item. So to do create item. Yay. So we have a title, and we can basically do some like, I don't know, completed is false. Title is equal to the title, and the title length is equal to strlen of the title. Then we don't need this, and we can basically create an item. So this will be to do mark item, and this will be to do print item. So to do mark item, item completed is equal to this, to do print item. So we're gonna get a bunch of errors. So Oh yeah, max to dos. Let's ignore these main.c for now. Okay, so it's actually, this is compiling. So to actually like serialize this to binary, what we're gonna do is we're gonna have char array, basically to do item to serialize, yeah, and we're gonna have to do, actually, yeah, let's focus on serialization for now. Oh, I clicked something. So let's actually fix the main for now. So this is the engine. Max to do's, I don't know. Let's define it here for now. Max to do's 10. Max title length. So to actually, so we're gonna say add command handler, and we're gonna do to do max title length. To do max title length, and to get this is to do create item. To do print item. Add command handler. This we will to do mark this item, and this should work now. Okay, so it compiles successfully. Now let's try to implement this to do item serialize thingy. So we go into the engine, void, actually it's supposed to be bytes, to do item serialize, to do item. And to figure out how many bytes we're gonna have, we basically, first things first, what we need to do is say, let's get title length. And title length is basically item title length. We can do it like this. The reason we're keeping it in the structure itself is because we need to know how much memory we're gonna need to allocate when we load from the binary. So we have the length, and to get that, basically, so we have the title length, which is basically, actually, let's call it title size. We're gonna have char size, buffer size is basically these title size plus size of an integer plus the size of a boolean. So we're gonna allocate a buffer, and what we're gonna do first. So first things first, copy the title length into the buffer. Yep. then copy the title, and finally we are gonna copy this thing. So first goes the title length. Actually, how does memcpy work? Copy block of memory. Okay, so we have a destination, source, and num. Okay. So this is like the starting point of the buffer. Then we have the source, which is basically the title length. Yep. And this is the size of int. Okay. Then we copy the title, which is basically this plus title size. And we go item title. All right, title size. Yeah, we'll see how it works. So we go title size plus size of item completed, and we go size of item completed, and then let's return the buffer. Let's just add a simple command, you know, just to see how it works. So we're gonna say this as serialize. Alrighty, so okay, serialize, and so when we serialize it, we actually need to include stdlib for the free. And what I'm gonna do is actually do some like this, and j is equal j. Yeah, something like this basically, and then I'm gonna go actually x, and after I free it, I can put it in a new line. Okay, so let's see, make dot, I don't know, add hello. Okay, this is very interesting. Okay, so first things first, actually, let's actually open a file. So we're gonna do file open. And why is this unexpected? Is it not going to work? File. Really? I thought it was in the input-output library. Really? Oh, I know. Okay, this makes much more sense now. All right, so we're gonna open the file, and first things first, let's say we're gonna write a magic number, magic value Todd to the file. All right, so number of to-dos. Yeah. All right, let's see how this goes. I know. A hello, a world. Yes. All right. To-dos. That bin. All right, it's Todd. But there is. So there is Todd. T-O-D-D. Then we have 2, which is an integer. And then we have something empty for some reason. Interesting. Okay, no. This actually has to also return the buffer that we created. Int buffer size out. And what we're gonna do is, to be honest, yeah, let's make it like this. Int buffer size out. Alrighty, so buffer size out. And what we're gonna do is buffer size out is equal to the buffer size. Yay! And now here we are gonna have a buffer size and here we're gonna have a buffer size, and instead of this we're gonna actually do something like this. Is this correct? Yeah. Yay. So hello world mark 1 serialize. Okay, shit apparently doesn't work. Now where are we going wrong? Well, theoretically, printf d SBS and buffer. The cat is being extra quiet today. That's nice. I love that. Excuse me, what the actual fuck? Okay, so that's a problem as well. For some reason, the title is getting smashed. All right, this is fine, I guess, to do. All right, so I fucked it up a bit. Maybe here, yeah. Let's do it simple. So we have a to-do item, which is an item, and the title length is string, and the title is this, and we stir copy. And after we quit, we should actually have like a cleanup function or something like that, so we don't waste memory. To do cleanup. Yeah, cleanup item. Let's have it here. Void to do. Yeah, let's make it free item. Doesn't matter. Free item. And when we quit, what we actually want to do is do something like this. Yep. All right. Todd, a hello print. Okay. Save. See? Simple. Okay, so next thing. So let's actually split this up. I don't know, like memory management. We have void to do free item operations, create item, mark item, print item, serialization. Yay. Okay, so while that is being done, what we're gonna do is open to-do.c. So okay, this is mark item, this is free item. Yep, all the fun stuff. Item operations. This is print and this is serialization. So what seems to be the officer problem here? We have Todd, and we have just one. Okay. Then we have a title length, but title length should actually be, I don't know, char, to be honest. Hello, welcome to the stream. Alrighty then, let's make this a hello. So Todd, T-O-D-D, then we have this, which is actually the size. Then we have 35. Okay. So this is H, and this is E. No, where is the E? E vanished somehow, but this is L, and this is L, and this is O. So, alright, something really weird is happening to my program, and I don't like it one bit. Haha, get it, one bit, because we're doing serialization. I'm such a funny man. Anyways, let's actually first map out the layout. So, layout of the serialized item. First things first, we have the title length, which is 4 bytes. Then we have the title, and then this completed. Oh, is bool actually? I see. Let's not do that. Let's actually do something like this. Type of unsigned char bool. Fucking C++. All right. I'll actually need this to include std bool. No, I won't. Define true 1, define false 0. Yeah. This should actually be this. Unknown type name bool. But where? To do h. Oh, sorry. Okay. So we have the title and the length. So first things first, we have 4 bytes. Or do we? No, we'll have, I don't know, 1 byte. Because it's more fun that way. So, we'll have the title length. Then we have the title and unsigned char is completed length is the size of that boolean. Or actually, I could probably go with item completed. All right. So this is like the complete buffer, but we'll also need to have the size of an unsigned char to put in its place. Now, what we're gonna do is have a buffer, and first things first, we're gonna copy the title length into the buffer. Yep. Then we're gonna copy the title. Yep. And then we're gonna copy the completed. And after all of that fun times, we'll just set the buffer size out to this. And now, this should be working. All right, then hello, serialize. Okay, it works. Some bytes aren't aligned quite properly though, but it's because they actually are. So we have TODD. Then we have 4 bytes for like the length of how many items we have. And then we have, so this is 5. This is the length of the title. And we have HELLO, and we have like a 0 to denote the end of strings. All right, let's try adding another one. Hello world. Yes. Okay, so this was very interesting. Alrighty. So, yes. What we're gonna do next is, actually, let's commit this. And let's not actually commit the binary. We'll actually name it Todd. So save file todos.todd. Where is it? Yes. Save file. To do serialization. Yep. Let's push. Alrighty. So yes. So we're also gonna need like deserialize or loading, but for that, what I would first like to do is light up a cigarette first. And is there like a linked list in C that I can copy because I'm too lazy? Or something like that. I just want a dumb dynamic array. Linked list library C. Yeah, generic. Something like this. A list. Yeah. Thank you, Kirsten. Is this available? Can I use this? There is no license. Alrighty. So let's just copy random code from the internet. Yay. ls.h. I'll actually put it in the README. Attributions. Because I was too lazy to write a goddamn linked list myself. Alright, linked list. This is the C file, and this is the H. Oops. Copy. Now, and the sorted linked list. I don't actually need to sort them out. Yeah, I don't actually care if they're sorted or not. And this is the print. It's more like a debug function. So this should be to do item node. And this is to do item node. To do item node. This is the linked list. Okay, llist.c. Yeah, I can do something like this. Let's copy this file. this one's a bit larger. Alrighty. And I'll definitely actually do something like this. If not define tag ls.h, define ls.h, and if. Okay. Copy. Yep. So what seems to be the problem here? Oh, everything is struct node. Yay. Okay, so I'll actually do something like this. So type def, and this would be to do item. And for this, I'll need to include the to do. This struct is actually gonna be something like this. And this is gonna be a node, to do item node. Type def. This is gonna be the node. Yep. And then I can go here. And everywhere that it's struct node, I can basically go to do item node. Alright, now everywhere that it's data will actually be an item. And this is funny. So yep, and everything that is void star is gonna be to do item node star. Yep, and here same. I don't actually need something like this. This is the push. 0. Yep. Okay. So, alright then. New item. Why is this? Then again. To do item. Node. Okay, this is gonna be the to do item. Okay, so this and this item is also just a to do item. Alright. Am I retarded? Probably. The pop should be like this. Alright. To do item node. No. Oh. Okay. And this should be an item. To do item node. Okay, I'll add it to the make file. So ls.o. Okay, ls.o must use the struct tag. Really? Oh. Really? Then this should be this. Okay. Okay, it's working now. Good. Okay, so why do we need a just simple? So when we create it, what? oh, okay. So what we're gonna do is unsigned int. We're gonna add a little unsigned int list length, and we're gonna have a fun time. So what we have to do to get the length of the list is basically iterate through it until it's null. So current length, yeah, basically something like this. Okay, cool. So first things first, we got this. Yes, we did. All right, let's go to main.c, and we'll have this and this, and we'll have a list of to-dos. Include engine. Okay, so first things first, we're gonna create an item, and if a list length of that to-dos is 0, we're gonna create it. Otherwise we're just gonna push it. Yay. Okay, for this, to be honest, we can just get away with. Oh, yeah, this is interesting. So how would we actually remove at the index? Okay, we'll talk about that later. So we have the list, and we can get the length of that list, right? So to do implement this. So to-dos count is actually a list length of that to-dos. Otherwise, what we're gonna do is create a new handler, mark command handler, and what we're gonna do is basically this. Mark command handler. Op index and a list length. To-dos op index item. Item that completed. Whoa. So we can actually go this and this because it's a pointer. Okay, to print all to-dos, we'll create a print command handler. Print command handler, and basically what we're gonna do is a list print to-dos, to-do print item. Yes. This will be taken care of later. Serialize. Now, I'm actually just gonna say write to file and make it W, and let's read from file, which is like load. Write to file, load from file. Okay. Let's see. So to write to the file, let's add another handler for that. So void write to file handler. And we can probably get rid of this, and this from here. Okay. So let's actually do something like this. Write the file handler, and this could probably go into the engine as well, to be fair and honest, but I don't know, we'll see when we get there. So we are gonna have a file. Alrighty. So we need to get to-dos count and a buffer size of 0. Now, what we're gonna do is this item. Yep. So let's see how this goes. It might crash very horribly, of course. So what's the issue? It should have gone here. Oh, because the list thingy failed. Okay, so we have a to-do item, and where's actually that code? So if pass list is null, this can be easy. Okay, this could probably be something like that. If the list is null, okay, that can be actually checked very quickly. Okay. All right. So we broke it again. But that's the fun thing, right? Breaking and fixing shit. Now, when we alright, so when it pops, we want to free the head, but we're actually gonna free all the to-dos. So and then return. And then we're actually gonna get int todos count, and we're gonna free the item, and we're gonna pop it. Okay, let's see how this goes. Todd Q. All right. Todd A. Hello Q. Okay, no seg fault. That's a fun thing. Okay, next thing, what we're gonna do, actually let's actually do something like this. Steal a linked list implementation. Okay, fun time. So to be fair, max to-dos is actually like int 32 unsigned max, which is a huge number, but yeah. So what do we have to do? What do we have to do? Let me think about it for a second. Besides fixing the obvious remove thing. Oh yeah, for some reason this died, the title. So why did the title die? Okay, this is the item. Maybe it's just this thing. Actually, I don't think this is the culprit. But to do. Also, my back is killing me, so that's always nice. All right. Let's see what we are gonna do. We're gonna fix it. Let's actually printf the title itself. Okay. This is interesting. So it works. Okay, yeah, it should work. That's true. Title linked Sterling. Oh. Let's try something like this. Well, yeah, programming is basically guessing random shit until it happens. So why does this not work? Okay. Okay. Why is this being weird? So we have a title length. Okay, true. Then we allocate the bytes. We copy the string, right? But still, what could it be? What happens if I don't know, say world? Where in the hell did it get this? Tess. Okay, I'm not sure which one of these is actually broken now. Yeah, let's actually do some like... Am I a retard? Am I an actual retard, actually? Okay, I'm an actual retard because for some reason I tried to access a linked list by index. Okay, so I'm an idiot. This is the pop to do item. Yes, yes, yes. Unsigned integer index. Okay. Just after the pop. Okay, index. So first things first, if index is greater than or equal to the list, just return null, please. Otherwise, yes, just return the item itself. It should be working right. So this is good, and let's list the print thing. So print cur item. Okay, so this doesn't work. This obviously doesn't work, but let's try it out anyway. To do print item list get to do's I. What the actual fuck? I'm very confused right now. So okay. Size of the list and size of the node. Okay, this is like the create, right? So we have a new node, right? And we need to allocate for that node. Okay, which is basically what? Oh. Okay, I see where the problem lies now. Okay, I see where the problem lies now. So, well, actually, to get like the item size is we need that title length, the title, and the boolean. So, yes. We're actually gonna need int list size is it's the size of the new item actually. And we should probably do some like this. I'll print it out just for debugging. Hello. So is it? Yeah. Okay. So that's actually like the node size, to be fair. And it is 8. So node size. Right. Then we say, do we need this actually? No. So this is like the node size, and this is like the new list, which is the size of the list. But we actually need the size of the entire list, and what we can do is list new list item is equal to new item, right? Next dot null is not a structure union. Really a list. So we have a to do. Okay, so we have a node with an item. Something like this, maybe. Okay, this seems more reasonable. So it should have that item. All right. Great, a seg fault. Okay, so we allocated 6 bytes for that thing. And for the list, what we need to do is actually, I'm confused why this needs to be, it should be, yeah, basically type def is basically a to-do list, and it should be just a... Okay, now I'm even more confused. So when we create a list, actually what we want to do is get a to-do item node, something like that, right? Something like that. A list create, right? So for the new list, this should actually be this, right? And we can malloc this to do item node. This is actually a L list. We can allocate there some data. Why am I doing this again? So what? This is if it's null. Okay, so new list is the new item, and the next is this. Okay. Returning a list, aka from function when incompatible. Okay, let's try this, I guess. And what we could do in the main, especially this, actually. So assigning a list. Something like this. Indirection requires the operand. Yeah, I'm really confused right now. What seems to be the problem? I don't know. Okay, so first things first, this is a... Let's do it like this, actually. To-do item node to-dos. Yeah, let's make it a little bit easier to work with. So a list. So this is like the to-do item node. Okay. This is like the to-dos. Why is this happening? Initializing, aka struct node. Okay, I'm an idiot. What? Okay, so this should be to do item node, right? Or something like that. And then this is the L list, right? And then this is the L list to dos, right? And it's null. Should it be this? Okay. A list create. Okay. So we have a new list, and we can just return a reference to it, right? Address of stack memory associated. Yeah, I know. So this should be something like this. What? Okay, so this can probably go like this, and then this, and then this. All right. New list, item, and the next one. And then this should be here. So we added a title, and we have like a node size. Okay, for node Todd. TODD. But why it's 8? Okay, that's kind of weird. So, to be fair, what we need is the new item title length plus the size of that new item title length plus size of new item completed. Yep. So that basically the node size. 6 bytes. TODD. Plus 1, I suppose, for the new line. For the 0 dot. Yeah. So we did that. We allocated shit. And then we return it. And then what we do, okay, what the hell did I do? So what we're gonna do is printf the list length, and this is maybe where it's gonna die. Okay, so if our list length of that to-dos is less than 1, we need to create it. And this is the item, right? Else we're just gonna push it. Now, let's read this again. So, is this leaky? Yep. What we need to do is we have like a new node. Okay. To-dos. So this list, new list. So this is the list. And we have like a node, really? Okay. Okay. So we got the title. All right. It's funny because I'm back right where I started. To do the opposite. My cigarette fell out. Let's see. So this is like the S. Let's actually make this happen. So what we're gonna do is int I title length, and instead of C, let's see this. Okay, Jesus Christ, I have no idea why it went there. So what we're gonna do now is so we created a node, all right, node size. How did it do that? Size of file list, size of node. So we have like title. Do we stir copy it good enough? So we're gonna do something like this. Gotta love the printf debugging. Okay, so the item title works. So this is actually breaking it. Let's see how. So we have this new node, which is basically, let's actually print it. To do print item, new item. The smoke got in my eye. All right. TODD. Yeah, seems to work. So the new item is actually good enough. Let's go to the to-do and actually scratch this. Okay, so it fucks it up somewhere here in the L list. So we need to create a new list. To create a new list is, this is node. So we actually, so this is a pointer to that list. Yes, so this is the size of list. Oh, some like this, I guess, then. L list, size of the L list. And then new list is equal to size of this, I guess. So new list. Yeah, let's just copy this thing because it's driving me crazy for quite some time now. So we have a struct node, which is basically a to-do item node, which is a new node. And then we do list, and we size of that, and then what we do is item next, and basically after that we return the new list, right? Something like that. C is an exceptionally fun language. Yeah, I'm still confused where it's fucking it up. Yeah, I don't know if I'm gonna be able to finish it today. Hopefully I will. So we have an item. Let's try to get like, I don't know. This is the new node. But where are we allocating this new node? We are not allocating it anywhere. Interesting. So I don't know, int node size is size of new item title length plus the title length plus this plus 1. Alrighty then, so this is like the new size. Let's print it out, I guess, again and again. A Todd. Yep. So what seems to be happening, we get the new list, which is basically the size of the entire list, which is a pointer. What we're gonna do, yeah, I should have kept it simple. New list. So we need to allocate that much for the new list. So we have a new list. We have a new node. And you know what? Let's just restart it. Fuck it. So let's say list.h. I know, if not defined, list.h. So define it. And if. Now let's just do this from the scratch. I feel I should have done this already. So we have a type diff struct. Struct of to-do list, memory management, to-do free list, right, to-do linked list node. Yeah, something like that. Type def struct list node. Then void list create ahead, list free, list add, list remove, void list at, or let's say get, I know. This can actually be a to-do item. Yeah, let's try it the Copilot way. Maybe it'll turn out much more easier, actually. include list.h, and then we're gonna need stdlib. Void list create list node, and we're gonna need a head. I'm gonna say the head is null. Then we'll need a list frame, which is basically something like this. Current item. And we could basically, so we got the next one, we're gonna free the current. But before we do that is we're gonna include to do.h to do free item current item. Okay, seems fine. Void list add list node head to do item. Head to index. All right. Yeah, this is also something I should do. List remove to do item list get. To do create item. Why the fuck would I? No. Oh. Yeah. Let's just say no. List get. And this should actually be a reference to an item, so this complete thing is broken now. Yay. Okay, to do free item. malloc to do. And this should be the address of the item. And this is about this. This is the get, and this is the length. All right. Main.c is gonna start crying. So we're gonna have a list node of to-dos. So if the list length is that, we're gonna actually list create. What? Okay. It's gonna be null. And then we're gonna do list create to-dos, and we're gonna list add to-dos and the item. Right? Okay. Then when we're marking it, we're just gonna say list length, something like that. So to do mark item list get to-dos op index, and this is the list length, this is the list get. And this can actually be list free. So no such file engine L list. Oh yeah, I need to change the make file as well. Jesus Christ. I didn't even get to create a file, so it failed automatically to do. Actually, let's do something like this. Then we get a command A. So why are you failing, my dear boy? Okay, it fails on the list create. To be fair, do we even need that? Let's say not. Oh. Okay, it still fails, I guess, on this thing. So let's try a printf creating list. So it tries to create a list, it allocates some memory. Am I retarded? Quite possibly, yes. Yeah, tons of warnings. This can actually be very easily created, but okay, file. To do item serialize and BS. Okay, to-dos. Okay, so it obviously failed here, and we're gonna need something like this, list free. So where's the list free? We have the current if head isn't null, then we free the head. Okay, so it failed on the print somewhere, right? Right. Somewhere on the list get, because it succeeded at adding it, right? So this is the list get, so it's less 0. List get. Let's see here. Get an item at index. Ding ding ding. Printf current index. Hey, hello. Current index. Okay, then it goes to the print, right? If item Okay. Interesting. Okay. So the first one is always null. Okay, that makes super much sense. What the fuck am I doing? Oh. Okay. This makes so much sense. Yeah, cry about it. Is this? So the first one is always null, right? Right. Yeah, so if list length of that head is less than 1, then we can actually just do something like this, I guess. No. So the list length. So this initializes the first thing and sets it to null. Oh. Well, this is interesting, actually. Very, very interesting. So, what we're gonna do is, so while the current is not null, okay, no, something like this. So, while current is not null, this should actually be like this. And then this should actually be something like this. Jesus Christ. Okay. Interesting. Very interesting, to be honest. Well, in theory, we could just use indexes from 1. Yes. Yeah. You know what? Let's just to do item. Yeah, something like that. Let's just do it that way. Main.c. And so if I know to do's is null, list create to do's item else we'll just add it. works. Now let's see, what is this? So this is fixed now. List. Yeah, we don't need to know which index, yada yada yada. Creating a list doesn't matter. So where's the list free? Current item title. To do free item. Pointer being free was not allocated. Yeah. Okay. For to do free item. This is gonna leak so much. Free current make. Okay, so it's dying somewhere here. At the free. Oh shit. No, I didn't mean to. God damn it. Where's the free? Where is the free? To do free current item. Yeah, let's do it like this. Okay. If the head is not null. Okay. Seems to be working properly. Oh, Christ. Okay, list free. Let's to do free item. Let's set it free. Okay, hello PQ. Okay. Maybe it died here. I don't know. So let's say for something like this. I don't know. Yeah, I'll investigate this later on. Let's see what's the problem. So we are gonna make it say hello. Did not see that one coming. Why is it list node? Really? Okay. Well, I guess with extra memory overlap, we get the fun thing. So this head should actually be the size of item Yeah, let's try like the size of item, something like that. Size of item. Title length plus item dot title length plus size of item dot completed plus 1. So we allocated all those bytes, and we're still getting the goddamn address wrong. Actually, are we? Are we? Or am I just being extra dumb today? Okay, yeah, I'm just being extra dumb today. Ignore me. So this was actually good. Yes. Yes. Alrighty then. So, hello. P. Okay, now when we try to write it, it fails. Good. Okay. Let's just do this. Let's just try making this work. Something like this. Okay, then when we have that, we'll have list remove. Yeah. Why is this completed? Okay, this is a bug. Obvious. Okay, let's say remove. No, it's not remove. Oh, well, remove command handler, and this will be remove command handler. Without this. Okay, remove one. List.c. So we will not do that. We will free the current thingy. 1a 2a free p. Okay, this is very nice. Yeah, let's just try it. Linked list and see. Example. Yeah, this is fucking embarrassing. Like, I don't even know how to make a linked list. Actually, why am I doing this? Is this like a dynamic list in C? Library STV, something like this. Yeah, let's look into it. klib STV. Yeah, let's look at STV. No. STV. DS. Dynamic arrays. Yeah. Yeah, let's try this actually. Fuck this thing. Fucking GitHub, can I just not sign in and just look at the goddamn code? Thank you, that would be appreciated. Okay, this. Okay, so table of contents. Yeah, this is basically what I need, just a dynamic array. Declare empty dynamic array. Yeah, basically what I need. So what I basically need is not this, and then I can get rid of this. Just a second, Mr. Cat. Yeah, let's see why it's not working. Ah! I did something. Yeah. I should probably just nuke everything at this point. Yeah. So, let's include third party STB DS and define STB DS implementation. Make, yeah. Should probably get rid of this. And then this. Yes. Okay, so find next to this T to do item to do's. Okay, let's see what the documentation says. Okay, AR free, AR len u, AR puff, AR put, AR insert. Is this actually that fucking easy? Like, okay. Our put to do's item. AR free. Is this gonna be that easy? AR free. Really? Really? Yeah, I'm just gonna try with GCC at this point. Make file. I think I have GCC, not sure. Linker command failed. Oh, it's still Clang. Undefined symbols. This line needs to be set globally by default. Don't you love it when there is nothing on Google? STBDS. Okay. So basically, we are put. Oh, did I do something wrong? We are put. Oh no. Okay. Hey, Greg, how's it going? Okay. So this is a hash map. LD. Yes. Oh, I need to define it on my own. Okay, I suppose. Okay. Really? Put. Okay. This seems to be interesting. Hello. Okay, this is interesting. Okay. So I basically do that. And then here I can basically, to do item is our oh yeah, I need this. So what I can do is to do item is at the index, right? I can mark this complete and set this to this, I suppose, our capacity or our size cap, our len. Yep. I'll be damned if it's gonna be this easy from now on. So for int I is equals 0. Okay, hello. I should have been using this from the start. Like, Jesus Christ, we lost like tons and tons of time. Okay, to do item output. Yeah, so Jesus Christ, I'm so stupid. Oh God. So Greg is biting me. Greg. So we're gonna need Arlen. To do print item, yes. And this is supposed to be like this. Okay. So remove output, Arlen to do's. Is there R replace or something like that? stbd, yes. Yeah, let's not read this. Let's read this instead. So R name R push. R swap. Tell R put. Interesting. Very interesting. So we basically have this. Okay. R free. Arlen U. Pop. Oh. Inserts into AP, moving the rest. Ardell swap. Is this gonna actually like properly work? Because if it is, Ardell, this is gonna be very fun. Okay. Jesus Christ, I'm an idiot for not using this before. So we can do this. Yes. So introduce count. Yeah, we can basically not do that. Okay. And then to get the buffer is basically this, right? Hello world, right? To do is that Todd. Okay, yeah, so moral of the story, use fucking libraries, if possible. So yeah, that's it. Pretty much. We can load from the file as well. Yeah, why not? So let me first use stb like a normal person. Totally didn't waste an hour. Okay, so to load it, yeah, this is gonna be actually really easy with like Mr. STBDS over here. So load from file handler. So what we're gonna do is open it, and we have TODD. Char magic. Int introduce count. Buffer size, read the magic value from the file. So we're gonna do this. We're gonna do actually this. Invalid file format. And we're just gonna add it here. Case load from file, load from file. Okay, so first things first, we need to have Todd. Right. Invalid file format. Is it? TODD, right. So first things first, yeah, actually let's skip the magic. fseek file. Skip the Todd magic value to do. So fseek, read the number of to-dos, size of int. Let's see how this goes. Make, okay, Todd. Yeah, correct. Okay, so read each to do. So for int I is equal to 0 is equal to do's count I plus plus. So first things first, we're gonna need to read the title length, right? Then we're gonna need to read the title, right? And we're gonna need to complete that, create the item, mark if needed. Input. Simple. Yep. So let's see. Chart magic. Let's see. Freed magic. Todd. TODD. Yeah, Todd magic log without the. Yeah, let's do it like this. TODD. Okay, let's try something like this. Okay. Got Todd. Oh! Todd does actually have that much characters. Okay. Done. Done. Gotta say, we don't actually have a limit now. Actually, we do. Include limits dash int max is unsigned 32-bit integer. Unit max. Yep. So let's say implement loading from file, and just for this, I just think I'm gonna, add a deserialize method in the to-do.h, and it's gonna have to-do item deserialize or something like that. Yeah. So you know what? Don't need it right now. We'll clean it up later. So yeah, we are starting to grow a pretty good to-do app, albeit without any user. So add a TUI for Todd. Add better logging for Todd. Add arguments for Todd, and so on and so forth. And now I should be able to load it. Yeah. Implement serialization. Deserialization or something like that for Todd. P mark free. Right. Quit. Load P. Yeah. I'm liking where this is going. And I think that would be all for today. Luckily, Greg, he wasn't naughty like the last time. So yeah, I'm pretty happy where this is going. I might optimize it a bit off screen or something, but yeah. Greg says hi again. And I'll let you know when the next stream is. Thank you, and see you in the next one. Bye bye.